that only leaves one thing. Oh, okay, it's got to be the buzzer is a 5-volt buzzer. Okay, that's starting to make some sense. Okay, so now we've got our parts sorted, except for the 3 resistors, but we'll come to that in a minute. I am going to move this forward and partly out of frame so I can use the actual, that's just going to keep flopping around on me. Get the circuit board, and let's look at the circuit board. Good. They have labeled on the circuit board, let me try that. I'm going to put it on a table here. I'm not sure if that's focusing or not. There we go. That should be focused now. And if I zoom in, hopefully you can see they have labeled the values of the resistors right here. They've also put the part numbers for just about everything on here. So we'll basically just assume that they got it all, and we'll deal with it if something's missing. It's basically, with these kits, it seems like process of elimination. You get everything that you can identify, and then whatever's left over, it's a little less of a mystery at that point. So let's see if we can't get, okay, 220, 220. These are all 220 right here. 1, 2, 3, 4, 5, 6, 7 of them. And a 0. Okay. But I can put, let's start building, folks. This was the 7 resistors. Oh, the other thing is sometimes they will put a number on this sort of labeling stuff here. It's actually because this all comes on a very large roll, and they're just cutting a section out of it. Let me get my magnifying glass and make sure this is actually 220. So far, each kit I've built, I've been able to do it by process of elimination. I know now I'm going to have a little bit of a problem. Okay, 2, 2, 0, and 0 zeros. Okay, 220. These are the resistors that go in first. At least that's going to be my instructions, since they didn't give us any. Let's see. Oops. Alright. That's all of them. Now I'm just going to form them, stick them in, and solder them, and I'll see you on the other side. Alright, well, we're only 7 components in, and we're already a half hour into this video. At least in terms of the raw time. That it'll be a little bit less with that time lapse, but I do want to say that I got kind of greedy at the beginning. I was trying to do 2 resistors at a time. I don't recommend that unless you have a lot of experience. It was causing me problems. It started going faster when I just went to 1, flip it over, solder it on, cut off the leads, do another one, flip it over, and so on. So that gets through the 220s. Now I want to do this 0 that's right next to that. Now that's probably just going to be one of these singles that only has... I got lucky again. Let me put that down there. See if I can zoom in on it. And that will have just a single black band on it. That is, basically it's a 0 ohm resistor. It's the same thing as just a piece of wire, but the nice thing about doing it with a resistor is you've got an actual piece of something that you can hold on to. Trying to bend the wires and stick them in there can be a little bit frustrating. So I'm going to get that on there. So you can actually shop for, you can go on Amazon, you can go on eBay, and you can look for either, I guess, resistor links, or it's just 0 ohm resistor. Basically what that is doing, and I don't know if this is going to come through, especially with the glare. Let's see if I can get rid of the glare. If you were to follow the lines here, that line, there's a line that comes down to here, and then basically it's picking up and going over there, because you cannot cross lines when you're making a circuit board. So what they ended up doing was they came along the back of the board, they hit that, and then it goes to the front of the board and jumps across and comes down to here, so that line can continue down that way. That is why they have that, and that is why they make resistors, or basically jumpers that look like resistors. They could have done it with a wire link, but I will give them a point for using a resistor in that case. Alright, I'll get rid of the extra pieces. Now, there are more resistors along here, and it looks like these are all going to be 1K. So the color code for 1K on a high precision resistor, which is what these ones with the blue background, which is really hard to read, or can be really hard to read, should be, let's see, 1K should be brown, black, black, wait a minute, brown, black, black, brown, I think. Yep. Brown, black, black, 1, 0, 0. And then the last band is always the number of zeros that you add on to it. So 1, 0, 0, and one more 0 gives you 1,000, or 1K. And there should be 9 of these puppies. So actually, I don't think that's 9 of them that I was looking at right there. So there's probably other places on the board to put these. And then I have to decide. Now these you can, it is not possible to put these in backwards, but I do try to make it so the color bands kind of line up. Just looks a little bit neater. There's a 1K going in. Oh, kind of lopsided. I think the hole spacing is a little bit off. So it's going to be hard to get it just the way I want it. There we go. I'll solder that one on, and back to the time lapse and a little bit of music for you. Alright, that takes care of 7 of the 9. While I was assembling it, I noticed that there's 2 more, one here and one there, of the 1K, so we might as well finish those off. I'm going to go ahead and form them and put them in. Alright, that takes care of the 1K resistors. That leaves us with 2 more. I know one of them is a 5.1 down here. So let's see if we can find that one. That's going to be a green, brown, black. Let's see, 510, and one more 0. It'll be 5100, or 5.1 thousand. So that is this one. Just to confirm, this doesn't have any green. Oh, it does. Wait a minute. This looks like brown, black, black, red. Which would be, oh, is that a 10K? 102 zeros, 10K. And that one is going to go here. Sorry. That one's going to end up going over here. So I'm going to take care of these 2, and we'll be back. Alright. I think that's all the resistors, and I'd like to say, but I can't really, that component, in terms of component count, we're halfway there. But I mean, if you think about the chips, the chip and the socket, there's a bunch of soldering there. Each one of these is going to have 10 pins, so that's 30 pins to solder there, so there's a lot of soldering left over. the next lowest profile, which is how I do this, is going to be the crystal. So let's put that on. And I may have to... Okay, the spacing is better on that one. Okay, that's pretty good. Now I am just curious, you know, my tools got magnetized a while back and things keep sticking to them. I'm just curious, let's see, R4 to 10, R3, there's one item that's I can't identify, R18, oh okay, that's the link, 5.1K, okay, I got all of those in, and it almost looks like what they're doing here is they're kind of also giving you the order in which to install these. No, not really. Because they're telling you to put the chip on before you put the socket, which doesn't make any sense. And the PC board is the last piece. So this is just a parts list. There are instructions. But I mean, I can't read Chinese, so I'm just going by my own experience here. So at this point, we've got the resistors. We've got the crystal. We're going to need the capacitors, I think, next. Will be the next lowest profile. So let's see, we've got a 30. Yeah, we got our 30s. Let's see if we can find those. Wow, I'm having trouble finding them. I see one of the 104. I see both 104s. Ah, down here, right next to the crystal. And that kind of makes sense because part of the circuit for a crystal to have it do timing for you. Crystal is the thing that generates a pulse every so often. I mean, on a regular schedule. This is what controls the speed of the processor. That's probably the best way to put it. So if you get a 12 megahertz crystal, if you were to reduce that to a 6 megahertz crystal, then probably your clock would be ticking off once every 2 seconds instead of every second. It's just how they do the programming. At 12 megahertz, that's 12 million cycles per second. 12 million little pulses, and you're only talking about having the clock tick once every second. So you've got 12 million cycles to do it, and the instructions for the processor could take, oh, I don't know, anywhere from 1 to 10 of those pulses. So there's probably built into the software that's on that chip is a long delay to wait for that second to actually finish. Ooh, that was close. I almost got solder in the hole on the next one. Let's see if I can't snip both of those at the same time. Save a little time. Now you got to be careful because you want to get the right capacitor in the right place. So that is definitely a 30, as it's actually written on there as 30. Get that in there. Oops. Gotta be careful it doesn't fall out while you're turning it over. And solder that one. Solder that one. Probably do a better job with that solder joint.
You need to heat both the pad that you're soldering to and the component lead in order to make an actual like welded junction. You don't want to just drag the solder. You don't want to put the solder on the iron and then dab it on there, because the solder has what they call flux in it, and that flux will dissipate before you get to it, and it will not make a good joint. So the trick is to get the soldering iron in place, heating things up, and then bring the solder to it. I'm just doing it kind of quickly because I have some experience. Let's see now. We got the 104s. Might as well get those in. We have these big rectangles here. Is it gonna? Yeah. Okay, the spacing, the lead spacing is reasonable. You want to be careful not to stretch the leads too much, because you could actually break them off of the component and then it won't function properly. So poke and solder. And I'm going to re-poke that one, because I didn't let it heat up very long. In fact, there's not enough solder on there. So poke and solder. And then some of the solder may come off on your iron. That's when you want to have something like this, which will allow you to clean the tip of your iron. Some people may disagree and say you got to do a sponge or something else. This is just what I happen to have. So that's one soldered on. And get the leads off of there. Ooh, it's a terrible job. And I just folded over the capacitor. Not really good for it. Alright, let's get one more on there. And the reason we do this from the lowest profile to the highest profile is because you do need to sort of check what you're doing. You can't just do that blindly, but the reason we do it in general is because it's harder to get to the low profile components to get them mounted on the board and soldered if you have high profile components next to them. It's easier to put the low profile on first and then the high profile next to it. Generally. There may be exceptions. Let's see. Okay, now we got all the capacitors on. Let's get this regulator on here. And I can see that that is between the two capacitors I just put on. That actually might make it slightly more difficult. And let me confirm this is the 7805. 78L05. 7800 regulators, 7800 series. They all start with 7.8. Are very common. They may come in different form factors. That's why this looks like a transistor, but is not. And I need to bend that out a little because they've spread out the leads. So I'm going to bend that middle pin out and then back a bit, and hopefully that will be enough to get this in. A little tricky. You got to get them all to line up. Well, let me get this in and then I'll point something else out. Okay, that's pretty good. I'll solder it on. Then I want to tell you about the curved side and the flat side. If you look at your transistors, and indeed this regulator. It's a TO92 package, I believe. And that's just the form factor that it's actually a chip. Or, well, something like that. It's a very convenient size package. It's small. If what you're trying to use the component for isn't going to generate too much heat, then you can use the smaller package. If you're going to generate a lot of heat, if that component's going to heat up, you end up with a different style of package that it ends up in, which will help it dissipate the heat. But what I wanted to point out, and I'm going to grab one of the transistors here, if you look carefully at this, I don't know how well I can zoom in on that. Let me try and focus right there. And if you look carefully, you'll see that one part is curved and another part is flat. Now, what they've done here with the circuit board is they've represented the curved part with angles. So if you just sort of imagine, you could make a curve out of that. And so that's telling you which side of the component goes in that direction. So in this case, the curved side is going to go that way, and the flat side is going to go that way. Now that's going to be a bit of work. I am going to take a break, and I will pop back instantly for you, but I'm going to take a break for now, and we'll come back and continue assembly. And just like that, we're back. And it's a couple of days later. I got sidetracked with a bunch of other things. That's just life for you. But in the intervening time, I hope, corrected the lighting. This should be a little bit better. And I've noticed a couple of things about this circuit board. Number one, this is not the same layout that they have in the listing. That's not a huge issue because it's the same circuits, the same components. It's just they changed the layout. So maybe when they were saying it was 7 inches by 2 inches, maybe that was accurate of the original circuit board. But they've redone the layout. It's still going to have this. Really, all you're going to see is a few switches and 3 different 2-digit displays for the clock. So it doesn't really matter that much. Electrically, it's the same. But the other thing along those lines is I noticed there's 1, 2, 3 connectors on this. There's 2 of them here and 1 more there. And I think this one probably goes there because we don't really have instructions, at least not in English, that we can go by. I'm going to have to figure all of this out. But the other thing I noticed staring at the circuit for a little bit is that this regulator here basically takes your 9 volts and knocks it down to 5 volts. And almost everything in here is powered by that 5 volts. So in theory, if you had a USB connector, which is a 5 volt connection, then that would basically, you're putting 5 volts in and then regulating it to 5 volts. In theory, that would work, and this clock would run off of a USB connection. So I could put it on a USB power bank, and it would probably run for weeks. I don't know how long it would run. I don't know what the power consumption is. We could test that at some point. I think that's beyond this video. This is mainly for assembly, and then we'll deal with hacks later. So I think what I'm going to end up doing is choosing one. There's actually 3 connectors, but one of them is parallel to the buzzer. That is the function where you can have an alarm, and when that alarm goes off, it can trigger something off of the board. So we'll look at that at some point, but mainly I want to get the assembly done on this and get it functioning, and then figure out how you set the clock and that. And that'll be the end of this video, and then there'll be follow-up videos for other functions. But just to make you aware that there are some differences here to what was originally in the listing. Yeah, so our next step here
I've got the soldering iron fired up, but before we can do that, I think the first thing I'm going to do is put these transistors on here. And to do that, I want to take these and bend the middle pin back towards the curved side. I'm going to need my glasses. Okay. I'm going to bend back. The basic thinking here, I'm going to go through one and then we'll time-lapse the rest of it. Because of the way that the holes are laid out on the circuit board, so I've now bent that back, and I'm going to bend it forward again, but further down, and hopefully that'll come through. And that is so that if you look at the holes on the board, and I'm hoping this will come through, but there's two up towards the flat side and one towards the curved side. So that's what I'm doing. What I'm doing is accommodating that, so I can get one transistor in there. The other thing I should do is double check, make sure this is actually a transistor, not another regulator, because they look the same, but it's possible. Oops, sorry about that. This is where I take the glasses off. Wow, it's really hard to get the right... Whoops! How did that happen? Okay. My light has a mind of its own. Wow, I'm going to need a light to see what I'm looking at. And this is supposed to be an 8550. Yep, that appears to be what that is. Alright, so I'm going to go ahead and put this in, solder it up, and then I will fast forward through all the remaining ones, but there's seven of them to go in. You just got to get the spacing right between all of these legs to get it to fit in there. It's really fiddly, and I've taken my glasses off. All right. If I was designing this board for this project, I would probably just leave the pins straight instead of bending them back like that. Or I would supply in the kit with the pins pre-formed. But there we go. I got it in. We'll get some solder. And we'll get this soldered on. And I may readjust the camera a little bit, but let's just go to time lapse and I'll get this done. Alright, yeah, I got them all in and tried to adjust the camera and deal with some little issues that are going on. I'm still working my way through, folks, figuring out how to set this up so they all look good. But the problem is, you know,
can't really go back and do a take two. I've already built it halfway. I don't want to unsolder all the components and pretend like I didn't put them in. So hopefully this is all still making sense. I've put in all of the transistors. I've got a couple of electrolytic capacitors. Let's try and get those in. Actually, before I do those, because those are a higher profile, I've got 4 of these LEDs. Let me just grab one, and hopefully I can point out here. Let's see if I can use that as a background. That there is one longer and one shorter pin. The longer is the positive, and these are all going to go. There's 1, 2, 3, 4 of these, and each one is marked with a plus. I'm going to try and get up closer, so hopefully we can get focus on that, and then hopefully you can see the plus sign, and that'll tell me where to put the longer leg. So let me focus back down. Whoops, I just dropped it. Alright, I'll go find that one later. Yeah, so I'm going to put all 4 of these in with, like I said, the positive side on the plus sign, or the longer leg on the plus sign. But you got to look carefully because they're rotated around here and there. They're not all the same positioning. I got 2 of them here. Now I want these to go in reasonably far, but I don't want to force the issue. I'd kind of like them to... Oh, there we go. They bottomed out. That's a good thing. Alright, now I can solder these, and I'll put the other 2 in, and we'll be back on the other side. Okay, that's done, but a number of things are fighting me here. So we're going to go a little bit further, and then I'm going to take another break, and I'll see if I can't solve some of the technical issues that I'm having. But we're getting close. I mean, relatively close. I've got the electrolytics that I was talking about. Now these are also polarized, meaning you can put them in, it is possible to put them in backwards. So on an electrolytic capacitor, and I tried to show this before, there'll be one side that has a band. That'll be the negative side, and you may be able to see there where it shows the negative. And also, at least on this one, the positive has the longer lead like the LED. So I'm going to put this in. We've got 2 of these. Yeah. And the hash marks that you see on the circuit board, I hope, here and here are the 2 electrolytics, and they've got hash marks where the negatives, and they actually have a plus sign for positive, so it's telling you how to put it on. Let's see if we can't get that to go in. That's good. I'll get the other one. You gotta get it oriented correctly. And the hole spacing is good enough that these actually sit down. That's a good thing. Maybe this will give some stability to the board so it doesn't flip around on me when I'm trying to solder. About ready to pull out the helping hands for this. And it should be 1 and 2. I'm going to make sure I get enough solder on there. Okay. That's got those. Make sure they're still on there. Good. Or not still on there, but oriented reasonably well on the top. Okay, that's got those. Well, they're slightly flexible, but that's okay. What I'm more concerned about is getting the display and getting this thing hooked up and working. Otherwise, this video doesn't get released. Let's see. Do I dare try to do this? We have a socket and we have a chip. They are bundled together with a piece of tape. That's the first time I've ever seen it done that way, but if it works, it works. Now, on the socket, if you look very carefully, and I'm going to try and get this up closer and hopefully it's obvious, on one side there's a little notch. On the circuit board, you will see the same notch. Now, actually, you could put this in backwards and it wouldn't be a problem. It's the chip that's more important. But I'm going to attempt to put this on correctly. Hope that the pins... Let me check and see if any of these pins are bent. Slightly. Be harder to get... What is this, 20 pins? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, 20 pins. Be harder to get it in if the pins are slightly bent. Ooh. That just sat right in there for me. Alright, things may be going my way here. Well, there's one little problem. Now that I've put these taller components on, if I put this down upside down and let go, that's going to fall out. So what I need to do is get the solder ready to go and do this. So, my recommendation to you, do the socket first. Do this like Big Clive does it, where you hold the circuit board and the solder in one hand. Once you get that first one on, it's mechanically connected. I'm going to get the opposite corner. Even if it's not seated perfectly, I want a mechanical connection. Now I can let go of the solder, move that out of the way, and I can put my finger against it and push it down from underneath, or push it up from underneath, which will bottom it out on the board. And I can go back and forth between these two until I'm sure that I am seated. I am seated. That takes care of that. Now it's just a matter of soldering the other 18 pins. And again, sorry for all the jerkiness of the video here. It's me bumping into the mount. It's one of those technical problems I need to solve. It should go reasonably fast. Don't rush yourself if you're doing any of this. Rushing usually leads to things like solder bridges and incomplete joints. And then when you're done with everything and you're wondering why it doesn't work, you're having to chase down looking for solder bridges and incomplete joints. The bridge shorts two things together, which is not what the circuit is designed for. And the incomplete joint means it's not making a good electrical connection. Okay, we're getting there. I wish I had the coordination that Big Clive has. I just watched him do a custom project of his own, a very simple battery charger, which could come in handy for this if I used that 6-pack of AA's. They're all rechargeables. By the way, I did a little bit more figuring on that while I was thinking about the USB thing. If you put 6 rechargeable batteries together, you get 7.2 volts. If you hook up the 9-volt battery, it'll be 9 volts to start, but both of them will eventually drop voltage. The voltage will be reduced as the batteries run out, whereas a USB starts and stays at 5 volts. The only question is whether USB under load, in theory it shouldn't, but whether it might drop below the 5 volts. I don't think those are yet. You see, I just made a solder bridge by rushing a bit. But there we go, the socket is now on. How many components does that leave us with? Alright, it looks like there's not much left. We've got the speaker, we've got putting the chip in, that doesn't require any soldering. We've got the connectors we're going to have to figure out, and we've got the 3 switches. The thing is the displays. Those are 10 pins each, so that's going to take a little bit of time. So at this point, I'm going to choose to take a break before I make myself crazy. And I recommend the same for you. This is not a half-hour or a 1-hour project. This is probably going to take you at least a couple of hours, unless you're exceptionally good at building stuff. So don't rush yourself. Give yourself a couple of afternoons to work on it, and eventually you'll get it done. You'll have the knowledge that you took your time, so you have a better chance of success. So with that, I'm going to take a break, and again, I'll be right back.